But in this situation, we are given that one end is opened. So since one end is open, that means one of these, it will be like this. So in this situation, since one end is open, so automatically this other pi r squared will be, but this is 2 pi rh, and together with pi r squared, because we are only having one. That's total surface area will now be area of the base circle plus curved surface area. And what's the area of the base circle? That's pi r squared. What's the curved surface area? That's 2 pi rh. So instead of having 2 pi r squared, it will be pi r squared. So take note of that, since one end is open. So in that situation, total surface area will now be, our pi is not given, times radius. Our radius is what? 7 square, which is that, plus 2. Our pi is not given, radius is 7, times height. What's the height? The height here will be 50. That's 50 meters long. 50 meters long. So in that situation, we're going to have, this one is 7 square is what? 49. 49 times pi, 49 pi. And this one will be 2 times 100, 2 times 50, that's 100. 100 times 7, that's 700 pi, plus 700 pi. 49 pi plus 700 pi, that will be 749 pi centimeter squared. So that will definitely be our answer. So that is option A. Find the angle suspended at the center of a circle by a chord which is equal in length to the radius of the circle. So let's say this, we have a circle like this, and this is the chord, this is the center. So the center, produce the center to this, produce center to you, and let's call this AB, chord AB, and center O. But the question gave us that, take note of this statement, of a circle by a chord which is equal in length to the radius of the circle. We have radius this. So that means the length of the chord, which is AB, is equal to what? OB and what? OA. So that definitely, that means this place is R, this place will be R, this place will also be R. So what kind of triangle are we having? We are having what? Equilateral triangle. And one of the properties of equilateral triangle is that we have 60 degrees. Each of the angle is what? 60 degrees. Is 60 degrees each. So what are we talking about? So the angle that will be suspended at the center without any calculation will definitely be what? 60 degrees. So we go to our option and pick the one that will match that. And that will be option C. If two smaller sides of a right-angled triangles are 4 centimeters and 5 centimeters, find its area. So we have the right-angled triangle like this. This is a right-angled triangle, and they said the two smaller, so automatically let this one with 5 centimeters and this one with what? 4 centimeters. And the question now has to find the area. Area of the triangle is what? Half base times what? Height. So what's half base? What's the base? 4. What's the height? 5. So we have this divided by this. 2 times 5, that's 10. 10 centimeters squared. That would definitely be the area. So this one's also very simple. That's option B. Then find the area of the figure above. If you look at this very well, you discover this is what is called composite figure. When you have two or more shapes or plane shapes. If you look at this one is not different from what? A semicircle, because when you have a circle like this and you are cutting into 2, that makes it what? A semicircle. So this one is like we are having a semicircle and also what? A rectangle. So the figure comprises of what? Semicircle plus what? Rectangle. So that means if you have to look for the area, it will definitely be what? Area of the semicircle plus area of the, so area of the figure. Area of the figure will definitely be equals to area of the semicircle plus area of the rectangle. That's what I'm going to have. So in that situation, what's the area of the semicircle? Area of the semicircle is half of a circle. What's the area of the circle? Area of the circle is pi r square. So area of the semicircle will be pi r square divided by 2. Plus area of the rectangle, that's length times breadth. So what is our pi in this regard? Our pi will be 22/7 times our radius. What's our radius? Our radius here will definitely be what? This one is the diameter. Take note of that because you are having 5 centimeters here, and this is the line drawn from the center of the circle and from one circle of the circle to the other, passing through the center is diameter. And we know that our diameter is 2 radii. So our radius will now be diameter divided by 2. So what's the diameter here? 5 divided by 2. So our radius is 5/2. So we come here, we write 5/2 times another 5/2 divided by 2. But this 2 divided in plus length times breadth. So let's consider our rectangle. Our rectangle is this. This is the breadth. This is the length. So automatically we have what? Length 15 times breadth 5. So if you do this now, this one will give us 22/7 times 5/2 times 5/2 times 1/2 plus 5 times 15. That would definitely be what? 75. So let's try and figure out this. So here we're going to have 22 times 5 times 5. That means 22 times 25. So let's use our mathematical set, our calculator. That's 22 times 25 divided by 7 times 8, that's 56, divided by 56, that will give us 9.82. So we have 9.82 plus 75. That will be 84.8. So we are going to have 84.82 as our what? Area, centimeter square. So now we have 84.82 as the area of the figure. Is that there the option? Yes. So approximately it will be 84.8 centimeter square. We'll go to our option and circle or mark the one that suits that, and that's option D. Now, question 21. The distance between two towns, P and Q. If the radius of the Earth is 7,000, find the distance between 2 points. That's P and Q. So they give us the radius. So this one is an example of what? This is the first time we are coming across this with respect to the question that we have solved so far. Longitude and latitude. Now, in this situation, we have to find the distance between 2 points. So here we know that our longitude is towards what? West and east direction, while our latitude is north and south direction. So if we draw our grid circle, and let's produce that line. This is the line of what? Greenwich meridian. So here is our 0 degree south. Here is our 0 degree north. Let's draw our equator. Here is our 0 degree west, here is our 0 degree east. So in this situation, we have our point P, which is 45 degree north. So it will be somewhere here. 45 degree north, so it's 45 degree north. Then we also have 30 degree west. So 30 degree west will be towards the direction. So this is our 30 degree west. Now we have 15 degrees south. So 15 degrees south, it will be somewhere here. 15 degrees south. So let's say 15 degrees south somewhere here. Then we have 30 degree west. That one remain the same. The question now has to find if the radius of the earth is. The question has to find it. So that means this place will be our point what? Where do you have it intersecting here with the P? Where you have it intersecting here, you have it here. So we trace this one to the origin. Trace this to the origin. So our theta is formed between this. That's our angle theta. And our angle theta here, let me draw it so that you get the clearer picture of that. So this one is just like Z. So parallel of latitude, so automatically you're going to have what? Then you have the same thing here too. Z. So what is the angle here? So we have 15. So this will be 15 and this place will be what? 45. So that means our theta overall will be what? 45 plus 15. But they are what? They are in opposite direction and that will be what? 60 degrees. So we're going to